Okay, so something that you might have noticed is that this is a lot like what we did yesterday in our exploration. So this is like 5 times x could be the area of a dark or a shaded spot in a rectangle, where it's 5 on this side and x down here. And 5 times 3 could be this space right here, where this is a 3 and this is a 5. So this is basically the same thing that we did yesterday, but we're exploring it using what we know is now called the distributive property. So I'm going to do another one. 12 times the quantity. This time, let's say our variable has a coefficient, 2y minus 3. Okay, so our variable has a coefficient, which means this is a 2 times y again. And then again, there's a little hidden multiplication sign. So multiplication is hidden in here. This 12 means groups of. So I know that there are 12 groups of 2y minus 3. So I know that there are 12 groups of 2y. So 12 groups of 2 times y. Okay. So again, I put the multiplication in there because that's what groups of means. And then I know there are 12 groups of 3, but I need to keep that subtraction sign in there. So 12 groups of 3. Okay. So let's do this. We're going to simplify. We're going to start with the left one. I have 12 times 2 times y. I know I can simplify 12 times 2, which is 24. But I don't know the value of y, so this stays the same. Cannot change. You cannot change y. So this is 24 times y. And then I keep the subtraction sign, and I get 12 times 3, which is 36. And again, because I don't know the value of y, I have no clue. I was not given a number to plug in. I cannot simplify this. This is as far as it goes. I keep it with the variable in it. In algebra, there are plenty of times where you're going to write an expression or an equation where the variable stays a variable. It just looks like a variable, and that's fine. You don't have to solve it. You don't have to figure out what the variable looks like. This is just an example expression. Okay, let's try another. Okay, so this one's a little different because I have 2 variables this time, and my groups of is half. Okay, so again, I'm going to put in those multiplication signs that are hidden. So this is half times 6 times y and 2 times z. So again, this is groups of. Okay, so I know there are half groups of 6y. So there's half of 6y. So half of 6 times y. And then the symbol in the middle is subtraction again, so I'm going to keep the subtraction. And then I get half of 2 times z, so half of 2 times z. Okay, and again, I'm going to simplify just like I did above. So I do the whole numbers together. Half of 6, or 1/2 times 6. This is half of 6. 1/2 times 6 over 1 is 6 over 2, which is the same as 3. Okay, so this becomes 3 times y, because remember the y stays the same. Then I keep the subtraction sign, and I've got now half of 2, or 1/2 times 2 over 1. 1/2 of 2, which becomes 2 over 2, which is the same as 1 whole. Okay, so this one becomes 1z. Okay. Yay! Again, because I don't know the values of y and z, I can't simplify any further. All right, I'm going to give one more example on a fresh piece of paper. Okay, and this example is unique again, but only because there are 3 things inside. So there are 3 things inside the parentheses, which is more than we are used to. But that's okay because the problem still stays. I still want to distribute that 9 to each one. So this is still groups of groups. And I'm going to multiply. So 9 times 6 plus 9 times x plus 9 times 2, which is 54 plus 9x plus 18. And that's as simplified. Well, actually, I could combine these two, but for now, that's as simplified as it's going to get.